Hello students, welcome to the lecture number 14 in the structure of the atoms. In this lecture we are going to discuss the four quantum numbers. The four quantum numbers are basically helpful to give us the information, total information about the electron in an atom. So today's video is the four quantum numbers are basically three of them that came out from the Schrödinger wave equations, the solution of the Schrödinger wave equation, and the remaining one that is comes afterwards from the scientist observations on the line spectra of the atoms. So the four quantum numbers, the first one, that is your principal quantum number. Principal quantum number is represented by the small n. From this quantum number, we will able to know many information about the electrons in the atoms, and it provides the following information. It provides the information in which about the cell in which the electron presents, and this principal quantum numbers is represent. Suppose this is a principal quantum number, it is represented by integers 1, 2, 3, 4, and accordingly cell is given by the alphabetic numbers, that is K, L, M, N. So this principal quantum number, first information that we can get from this is about the cell, in which cell the electron present. Second information that we are going to give, that is the distance from the cell. Distance from the cell means higher the number, so higher the value of the n, this means the higher the distance of the cell from the nucleus. That you can see, that is the, suppose the radius of the cell is R1 and second cell is R2, third cell is R3, then you can put this relation that R1 is less than R2, R2 is less than R3, and dot dot, that is Rn, and the radius of this Rn subcell, Rn cell, that is given by this formula, that is, this is a very important formula. From this formula you can able to know the distance of the cell from the nucleus, that is given by this 0.529 n square by z, where n is the quantum number and z is the atomic number of the hydrogen and hydrogen-like species. So you can see, as the value of the n is increasing, the distance from the cell goes on increasing. The third information that you can get from this principal quantum number, that is the energy of the orbitals, that is En is given by this minus 3112 by n square z square by n. So you can see, as the n is increasing, this value is less negative, means the energy is going to increase. So this is in the unit of kilojoule per mole. So from this The energy of the orbitals you can get from the principal quantum number. As the principal quantum number is increasing, the energy of the orbitals goes on increasing, because this value will be less negative, means it will have the higher energy. So we get the three information, that is about the cell, distance from the cell, and energy of the orbitals. So fourth information you can get from this principal quantum number, that is number of subcells. In a cell having the n number of subcells. Suppose this is a cell number 1, it will have the 1 subcell. Cell number 2, it will have 2 subcell. Cell number 3, it will have the 3 subcell. Like this way, from this principal quantum number, you can able to know all informations that we have already discussed. Then this information we are going to get the size of the orbital. Higher the value means higher the value of n. Higher the value of n means the higher the size of the orbitals. Means that higher the value of n means the electron is far apart from the nucleus. Then also we get the information from the principal quantum number, that is the number of electron in a cell. It is given by 2n square. It is given by 2n square, where n is the principal quantum number. N is the principal quantum number. So these are all the information that we can get from the principal quantum number. That is it tells about the cell, it tells about the principal number of orbitals present in it, it tells about the size of the orbital, it tells about the distance of the orbitals, distance of the cell from the nucleus. It also tells about the most important part, that is the energy. That is all we can get the information from the principal quantum number, and you can easily understand this principal quantum number is very important quantum number that will decide all other quantum number also. So next quantum number that is important, that is we are going to discuss, that is azimuthal quantum number. Next quantum number that we are going to discuss, that is the azimuthal quantum number or subsidiary quantum number or orbital angular momentum quantum numbers. And this quantum number is represented by the small l. From this quantum number, we will be able to know that the cell is subdivided into the subcell or sub-levels. And the value of this azimuthal quantum number depends on the principal quantum number. So we can write this very important information, that is, for a given azimuthal quantum number, it basically represents subcell, and this azimuthal quantum number depends on the principal quantum number, that is n. And for a given n, L can take the n number of values, and it is ranging from 1 to n minus 1. That means you can see, if is n is equal to 1, then L will have the one value, that is 0. Because that value, number of value of the subcell, principal quantum number, azimuthal quantum number, that depends on this n. As n is 1, then L will be also at the only one number, that is 0. When n equal to 2, then L will have two values, and these two values are 0 and 1, right? When n equal to 3, the L will have the three values 0, 1, 2, and when L equal to 4, this L will have 0, 1, 2, 3 values. So when L equal to 4, the value is number of value is 4, 1, 2, 3, 4, and its value is this. So this is a very important thing to understand. So from this azimuthal quantum number is going to say about the number of subcell present in the cell. And we know cell is consisted of the one or more than one subcell. And how many subcell in a cell will have, that will be given by this statement. You also remember that. So nth cell will have the n number of subcell. That is a very, very important thing to understand. This means we can write this in this way. So for the cell, suppose cell is A and corresponding is principal quantum number is 1, then subcell L will have the one value, that is 0, and its subcell notation that we will do afterwards. First we understand this. When cell is L, it will, the principal quantum number 2, it will have the two subcell number is 0 and 1. When it is M, it will have the principal quantum number 3, and it will have the subcell azimuthal quantum number this. When it is N is 4, it is have the principal, it is subcell 0, 1, 2 and 3. It is 4 and it is having the 4 subcell azimuthal quantum number, or you can say this is the subcell. Now for each and every subcell notation, that is azimuthal quantum number, for azimuthal quantum number, there will be a notation. The notation is when it is 0, L equal to. So you can see the azimuthal quantum number. When it is 0, it is S. When it is 1, it is P. When it is 2, it is D. When it is 3, it is 4, and it is only 4, it will be G. This is the notation of the subcell. And now we suppose this is K cell and this is principal quantum number 1. So what will be the subcell notation? It will be 1s. When it is quantum number principal quantum 2 and its cell is L, then it will have the total 2 subcell, and its notation will be 2s and 2p. When for the case M cell, that is will have this principal quantum number 3, it will have the 3 subcell. Cell number 3, so subcell number of subcell is also 3, and its notation will be 3s, 3p and 3d. And when it is N, that is a cell, its principal quantum number 4, it will give us the 4s, 4p, 4d and 4f. So you can see all those things that according to the subcell, according to the cell, the subcell notation is like this. So we understand the azimuthal quantum number. It will going to give us the about the subcell. And another important information that we is giving, that is, it will tell that the 1s orbital is less energy than 2s orbital, 2s orbital less energy than 3s orbital, like this one. Most important part of the subcell, it provides us shape, that we will discuss. These two things we will discuss separately in the different lectures, that how this energy of the orbital going to influence for this by this azimuthal quantum number, and it's provide the shape of the orbital. The shape of the orbital is governed by in which subshell it is present. So this will give a shape of the orbital. And fourth is the orbital angular momentum, that is also given by orbital angular momentum. Angular momentum, and that is represented by L, and it is given by h by 2 pi is equal to L into L plus 1. So you can see, if you know the azimuthal quantum numbers, which is 0, 1, 2, 3 as per the number of the quantum principal quantum number, it will give the orbital angular momentum. So if you put this L equal to 0, and that will be the orbital angular momentum for the S subshell. Okay, S subshell, in that subshell there is the orbital, that we will not discuss now. So all those information is going to give you, that is first, that is number of the subshell which is present in the cell, that will giving by this azimuthal quantum number. Number 2, that's energy of the orbital. Number 3, the shape of the orbital. Number 4, that the orbital angular momentum. Okay. This is the third quantum number that we are going to discuss, that is the magnetic orbital quantum number, and this is represented by the small m. What it signifies? It signifies the number of orientation of the electron in a subshell, and that is the number of orbital present, and this is given by for a particular value of L, and this value, the orientation of the orbital, orientation of your electrons, that is depend on the, the value is depends on the L, that is principal quantum number, depends on L. How it depends on L? Now it takes the value, it takes the number, first it will takes the number, that is 2L plus 1, takes the number that is 2L plus 1 number, and its value ranges, from minus L to plus L through zero. So magnetic orbital quantum number is going to give us the information about the how many orientation that a orbital or electron can take place, and this will give the number of orbitals present in a subshell. So it will take the value of 2L plus 1, and this ranges from minus L to plus L. Now we formulate, now you see how this number of orbitals in a subshell we can able to determine. When the L equals to 2, and it will have the two numbers, two subshell number, L equal to 0 and it will be L equal to 1. When L equal to 0, that M will be already known, it will be 0, and it will be the one orbital, that is 2s orbital. Name of the orbital is 2s orbital because it is in the second cell, and second cell will have the another subshell, and that number is 1, and it will have the 3 orientation, that is plus 1, 0 and minus 1, and this value we can say this will be 3 orbitals. This is basically will have the 3 orbitals, 3, that is we can write the 2px, 2py and 2pz. Z. So we can see in the second cell, there are total orbitals present is, how many orbitals present? That is 4. Number of orbital is 4. Cell is either 2. Here it is only 1. Now M cell you have the principal quantum number is 3 and it will have the azimuthal quantum number 0, 1 and 2. And here you can see the M is equal to 0 and it will be 1 orbital, that is 3s orbital. And for the subcell, it is the M, when n equal to 3, it will have the 3 subcell. So one subcell, second subcell, it will have the number +1, 0 and -1, and it will have the again 3 subcell, and its name will be 3px, 3py and 3pz. For the subcell number 2 with the azimuthal number 2, it will have the orientation, that is will be -2, -1, 0, 1 and +2. You can see 1, 2, 3, 4, 5. So total 5 orbitals, 5 orientation is possible. So we can write the orbital is 5 orbitals and it is having the 3d5 orbital. 3d5 orbitals. Okay. So this is for the 3, and for the cell M, this value is, we know it is 4. N is 4 and the subcell, it will have the 4 subcell notations, 4 subcell 0, 1, 2, 3, and accordingly it will have the M equal to 0, means orbital is 4s orbital. M is equal to -1, 0, 1, it will have the 4px, 4py and 4pz. When this is M is equal to 2, that is -2, -1, 0, +1, +2, it will have the 4d orbitals, and when we 3, it will have the -3, -2, -1, 0, then +1, +2, 3. Total 1, 2, 3, 4, 5, 6, 7. So the 7 orbital, and this is called the 4f orbitals. So you can understand how the principal quantum number going to influence the azimuthal quantum number, and azimuthal quantum number going to influence the number of orientation of the orbitals in a subcell. Okay, I think that is clear to you. Next quantum number that we are going to discuss, that is the spin quantum number. Spin quantum number is represented by S, and this will signify one thing, that the electron is having the spin, and this can take the value of +12 and -12, +12 and -12. So when the electron is there, electron can move in this direction, also it can move in this direction. So this quantum number will have the +12 and -12 value, and that will going to give us the intrinsic spin of this electron. And that is all for this today's video. In this today's video, we have discussed the 4 quantum numbers, that is the principal quantum number, what it signifies is, that you understand. It will give us the energy level of this orbital. It will give us the distance. It will give us the shape of the orbitals. Second, we understand the azimuthal quantum number, that will give us the number of shape cells in this cell. Then the number of orientation given by the magnetic quantum number, and last, that is spin quantum number, that will be going to give us the spin of the electrons, that is the clockwise direction or the anti-clockwise direction. And that is all for today's video. In the next video, we are going to discuss some examples related to this principal quantum number, 4 quantum numbers, and some we will discuss of the shape of the orbitals. That is all for today's video. Thank you.